Good morning. Today we're going to do 6.1 Reciprocal and Quotient, Reciprocal Quotient Pythagorean Identities. Just as a starting point, I wanted to talk about the identities. Identities are, if you can read about these in your textbook for sure to get a little bit more information, but in general, identities are ways of us being able to switch or change their equalities, so they're ways of changing certain things inside of an equation or an expression through trigonometry because of these equalities to simplify things. So this is what's going to be happening. So the reciprocal and quotient identities are the ones there, titled right in front of you there, and you can see some of them you've used and you understand already, like the reciprocal of cosine theta is secant theta, reciprocal of sine theta is cosecant theta. All these different things are things that we already talked about. The other one that's newish is the Pythagorean identities. I drew the picture of the first quadrant there. So this is the first quadrant, this top right picture. And just did a unit circle picture, just instead of using the values, remember that the x and the y in coordinates in the unit circle are equal to cosine theta and sine theta, respectively. And that triangle that gets made, the reference triangle that gets made, is a right triangle, and because it's a right triangle, we can represent it using Pythagoras. A squared plus b squared equals c squared, which ends up being sine squared theta plus cosine squared theta equals 1 if we're using that triangle. So it's a right triangle, therefore, and I said that. Now the other two Pythagorean identities are just mathematically switched to get to the other one. So if you divide everything in that first one by sine squared theta, you get the second one. If you divide everything by cosine squared theta, you get the third one. So it's not really that important to know the other two in a sheet like this, but and I think when I was a kid, I only got the first one, and then you'd just always deal with that. But either way, these are the ones that have been given to students for the last 20 years. So we can kind of give these ones to you guys, and these are the identities that we're going to use. Now the rest of the stuff is going to be math stuff that we do to do these simplifications and or things that were going to happen. And so let's kind of get into it. You can also look in your textbook at some of the stuff, and you can see that when you look at the outline for this, that I have a worksheet that goes with the textbook. I like the worksheets a little bit better. They're a little more clean as to what I want you to be able to do. So I spent yesterday working on making these notes a little better, because it's not quite the way I would do notes for this section, but it is the way I'm doing notes right now. So let's see how we do. Okay, so the question here, number 1, says, which is the only question I think, you simplify each expression with only one of the 6 primary to one of the only 6 primary trigonometric ratios and or a constant. So at the end of the day, you should just end up having just a single trig function. So it should say, the answer should be cosecant theta or sine theta, something like that. Maybe sine theta plus 1, which is the and or constant thing, or just 1, which would just be a constant. So this is all a simplification thing, and I'm just going to show you how to do it. And what you're practicing in this first day is just getting good at these kind of puzzles. And these puzzles are, let's try and get these things down to a single trigonometric function. So I'm going to do a few of them. I'm not necessarily going to do them all. I can't remember how many I have here. I have 9, 10, 11, 12 of them. That's quite a bit for me to try and go through in a day. What I'm probably going to do is it's 13 of them. I'm going to try and do a few of them, and then what I'll do is you can look at my work for the other ones. In other words, I'll maybe do half right now, and then when you go back and you look at the completed notes in the file, it'll have the other half done, and you can just have a look at how I work through them. So let's just start with maybe 1A here. I'm going to do 1 or 2 from each kind of row. So let's start with 1A, and just so we understand things. So one of the primary strategies is to change everything to sine and cosine. So in this first question, I would put another equal sign here, and cotangent theta, which you can look up at the top. Cotangent theta is equal to cosine theta over sine theta. So what I do is I put a big fraction bar, which represents the fraction bar in the expression at the beginning, and then I go cosine theta over sine theta. And on the bottom, cosecant theta is equal to 1 over sine theta. Now that you can see that up above here as well. So it says cosecant theta is equal to 1 over sine theta. So these four, I don't use the tan one where it goes to cotangent very much, but I use these ones all the time. That means I'm basically taking everything that's not sine or cosine and I'm changing it to something in terms of sine and cosine, because they're all in terms of sine and cosine. Okay, so that was my first step. You can just ignore the cotangent one. I use it sometimes, but not as often as these other ones. The next step, and you want to be tidy, you got to get used to being tidy because we're going to do proofs later. You'll see what those are. You want to get good at showing all your work. So if you're dividing a fraction, in a fraction, you can multiply by the reciprocal, which is what I'm doing, and that ends up giving us cosine theta, which is our answer for this. No big whoop. Right, so let's do C, maybe. C is 1 over, and it'll be cosine theta over sine theta, which is cotangent theta, and secant, which is 1 over cosine theta. Again, you can look up above. I'm just using those, and you should always have those out. There's actually a sheet I made called Identities, which is in the file folder at 2, and you should take that out and have a printed piece of that so you can always have it in front of you when you're working. You have to do tons of these. Like I say, if I was teaching the class with you, I would just say we've got to kill a bunch of trees. So the cosines cancel out. So what happened here, sines canceled out. Here the cosines canceled out. And then you're going to multiply by the reciprocal, which is just sine theta, and you're done. Okay, so that's another one of those. I'm going to do the third one as well, or fourth one as well. This was a little bit weird, but it's got a couple of fraction math that we have to get better at. 1 minus tan theta is the same as, so I'm going to put an equal sign, I'm going to put a big fraction bar. It's going to be 1 minus sine theta over cosine theta, and then down below I have cosine theta, sine theta, minus 1. Right, so I've changed tangent theta and cotangent theta to the respective side of the identity that's in terms of sines and cosines. Then I'm going to change the ones to be so that I can actually add fractions together. Very important that this adding fractions together before we divide. So this is the same as saying cosine theta over cosine theta, that's 1, minus sine theta over cosine theta. And then I have cosine theta over sine theta. My denominator is sine theta, so I have to make the 1 sine theta over sine theta. So sine theta over sine theta is 1, and cosine theta over cosine theta is 1. Just make it equivalent fractions with common denominators, which leaves me with cosine theta minus sine theta over cosine theta. And then I have cosine theta minus sine theta over sine theta. Okay, so this is, at this point, when I've simplified the numerator and the denominator to be single fractions, so you can see that when you look at the first things, I just have a single fraction bar in the numerator and a single fraction bar in the denominator. This is when I can finally do the multiply by the reciprocal. So I can go do this now. I can go cosine theta minus sine theta over cosine theta, and that be multiplied by sine theta over cosine theta minus sine theta. So this is where I was able to do that part. Now here's the important part. I can reduce here and here. Now if I'm going to reduce anything that's in a binomial form with that is added and subtracted, I have to have full binomials the same. I can't pick and choose. So a big mistake, I'm going to do it with green pen and I'm going to erase it, but a big mistake is what students do things like this where they go, oh, here's a cosine theta and here's a cosine theta, and I can cross those two out because they're in a fraction, but the problem is that the top is a denominator, or top is a binomial and the bottom is a monomial, and we can't do that in math. That doesn't work that way. So you have to be careful about that. So you can only divide full or reduce or simplify or cross out full binomials that look the same. So cosine theta minus sine theta and cosine theta minus sine theta are binomials that are identical to each other. I can cross them out, and that leaves me with sine theta over cosine theta, which is equal to tan theta. Okay, so that's that one. So again, these things can get pretty big. I tried to give enough space, but sometimes it just doesn't work out. Okay, so those are all just using, the first kind of group there is just using the reciprocal and quotient identities. We haven't used any Pythagorean identities. So let me show you how to use Pythagorean identities and see how that goes for you guys. So let's do, first of all, let's do our letter E. And it has cosecant squared theta and cotangent squared theta. So if you look at the third Pythagorean identity at the top, it has cosecant squared theta and cotangent squared theta. So I'm just going to do a little, they're going to write that one out again. That's 1 plus, green here, 1 plus cosecant squared theta equals cotangent squared theta. Now this is the actual identity above. Now you have to recognize that I'm going to manipulate identities all the time. So when we look at this identity, just to make sure I got it right. Oh, I didn't do it right. Oh my gosh. Just started to look wrong. Okay, so when I look at this identity, I don't necessarily have, make sure you have your sheet in front of you, because I just made a mistake that's crucial. You got to make sure you have the right identity in front of you. But once I have that identity and I'm looking at this and I'm going, oh, I got cosecant squared theta and cotangent squared theta, maybe I can make this work. What I'm basically going to do is move this over, and I end up having 1 equals cosecant squared theta minus cotangent squared theta. Now, this is just me manipulating that one Pythagorean identity, and often you just, by switching sides, you want to isolate one of the things, and you'll see that sometimes those things will make your life a lot easier. So what happened here is this one right here is the same as this up here. So those two things are identical to each other. So what happens is if I see cosecant squared theta minus cotangent squared theta, what I can do is I can replace it with 1. So you can see that my next line in the actual solution would be equal to 2 times 1, because cosecant squared theta minus cotangent squared theta is equal to 1, which leaves me with the number 2. So it could end up as a constant in these questions. So it doesn't have to be a single trig function. It could just be a number, or it could be a trig function with a number, like cosine theta plus 5 or something like that. Okay, that's that one. If we look at G, let's look at G. It's got a couple things going on too, but let's have a quick look at what's happening. So first of all, when I look at G, I see sine squared theta, cosine squared theta, sine theta, and cosecant theta. I'm going to get rid of cosecant theta and make it sine theta, 1 over sine theta. So let's do that first. Okay, so what does this do? So when I change that to that, I like to make sure that you'll see me kind of make fractions out of things that aren't fractions, like sine theta over 1 times 1 over sine theta. That's going to be now sine squared theta over cosine squared theta plus 1, because the sine thetas will cancel out. It'll end up being sine theta over sine theta. And then I want to have a common denominator to put these together. You'll see me always be doing this stuff. Okay, so this time I need cosine squared theta, so I multiply top and bottom by cosine squared theta, and then I have a common denominator, which leaves me with this is a fraction, right? So you're always trying to get it to be a single fraction. Now sine squared theta plus cosine squared theta is equal to 1. That's our classic 1 from above. And 1 over cosine squared theta is the same as secant squared theta. And that's the end of it, right? So just so we're clear, I'm just going to put the identity in green beside the one I'm using. So sine squared theta plus cosine squared theta equals 1, right? So I'm just using this one, and if you highlight stuff in yellow again, I'm taking this whole thing out and replacing it with 1. And so the Pythagorean identities you got to get used to it. They have to be squared. You can't just do sine theta plus cosine theta. It has to be squared. But once they're squared and you can see it, you do it. So as you're working through these things, you have to get used to the kind of game that's being played, right? Like you can look into the details a little bit more in the textbook, getting some stuff into your brain. But basically what we're trying to do is figure out a way to simplify. And we're using algebra, a lot of fraction math, and we're using those identities above to get through things. So let's flip the page here, and I'm going to do these ones, a couple of these ones. So let me do H. So again, I look at H. When I look at H, I see cosine theta, sine theta, and cotangent theta. So again, one of my strategies that I want to get you used to is to take and get everything written in terms of cosine and sine. So this is the same as saying that, right? So, and again, you can see when I put those fractions together, this is multiplication that we're doing here. Those are multiplied together, so I can cross out the sine theta. They're not added on the top, they're multiplied. So that's when you can cross out things. We end up with cosine theta over cosine theta is equal to 1. No big whoop. You just got to keep doing these things. So this one, for instance, well, I'll let you try that one. Let's do the next one, J. That's going to be 1 over cosine squared theta plus 1 over secant squared theta. Now they're separate fractions, so when you got separate fractions, you can simplify both those by multiplying by the reciprocals, which ends up giving us cosine squared theta plus, it's supposed to be sine squared theta, sorry, sine squared theta is equal to 1. That's the same as sine squared theta plus cosecant, or sine squared theta plus cosine squared theta. Again, if you're not quite understanding what's happening here, this is A over B over C, which is equal to A over times C over B. Now, because a lot of these are 1s, we're doing 1 over B, which is equal to 1 times B over 1, right? So that's what's going on. C I was using. So that's what's happening. I wanted to get our C. Right? So sometimes, and I'm just doing like that single one there. So that's that's just fraction math, but that's what the fraction math we're doing. It's just some of those things are 1s. Now, the other thing I would have done in this question is probably just said, okay, that's automatically equal to cosine squared theta plus sine squared theta, because you could go up here and you can see, because of the reciprocals again, secant is equal to 1 over cosine, so therefore cosine is equal to 1 over secant, and furthermore, cosine squared is equal to 1 over secant squared theta. So you can kind of go and jump straight to that if you need to. But you can do it mathematically as well by doing or change everything to sines and cosines and then do the fraction math. All right, last couple here. Okay, so I'm going to do K and M. And let's see what K looks like. So K is not good right now, so this is a good one though to show what I do with the fraction math as I'm working through. So with K, some space hopefully, I'm going to first of all change that secant to 1 over cosine. Actually, let's just leave it that way, but what I'm going to do at the first part is I'm going to need a common denominator, and the common denominator is going to be sine theta times cosine theta. So that first fraction, I'm going to make some space here. And the first fraction, because I need it to be sine theta cosine theta, needs to be multiplied by cosine theta over cosine theta. And the second fraction needs to be multiplied by sine theta over sine theta. Now what that does is it gets us to have a common denominator of sine theta times cosine theta for both fractions. And when we're adding fractions, we need to be cognizant of that. We're going to be having common denominators. So this next step gives us secant theta cosine theta minus sine theta all over sine theta cosine theta. Okay, so that's first off. So I've made them so they have a common denominator. Now I'm going to simplify the numerator. So take your time on these things and give yourself the steps. I'm not trying to make it so it's you want to do as many steps as possible initially, and definitely when we do proofs later on, you want to be doing those all the time. Lots of steps, I mean. Okay, so I changed secant to 1 over cosine, and I'm going to multiply it to cosine theta, so it's cosine theta over 1. You can see they cancel each other out, left with just 1 minus sine squared theta. And I get that. Now I'm going to put down my Pythagorean identity I'm going to use. So you can see that here with this Pythagorean identity, the one that's, I'm going to be taking this out and I'm going to be replacing with cosine squared theta. And you can see that the cosine theta, one cosine theta from the top and the cosine theta and the denominator are going to cancel each other out, and I'm left with cosine theta over sine theta, which is cotangent theta. Okay, so a lot of work going on there. You can see that I used a Pythagorean, I used a reciprocal identity, Pythagorean identity, and a lot of fraction math. There's a lot of stuff going on there, and the difficulty is being able to show those steps clearly. You're going to see that's going to be a difference maker later. Now the very last question I'll do is M. Again, it's got a bunch of stuff going on, so let's do these things. Often what I'm doing is I'm cleaning up numerators and cleaning up denominators before I kind of put fractions together, so you see me do this a lot. So let's make a big fraction bar, and I've got 1 plus 1 over cosine theta. So that's what secant theta is, 1 over cosine theta. The denominator is sine theta plus sine theta over cosine theta. Okay, so in the denominator, you can see that I need to put them both over cosine theta. So this is going to be, in the numerator, sorry, it's going to be both over cosine theta. So this is going to be cosine theta plus 1 over cosine theta. I better do that in 2 steps. Cosine theta over cosine theta plus 1 over cosine theta. So that's my numerator. 1 is cosine theta over cosine theta. And the second one, that sine over, this sine over 1 that I have here, needs to be over cosine theta so I can put it together. So it's going to end up being sine theta cosine theta over cosine theta plus sine theta over cosine theta. Okay, so here's where we're in pretty good shape. So we're going to now put both of these fractions together. The numerator fraction is going to be cosine theta plus 1 over cosine theta. And the denominator is going to be sine theta cosine theta plus sine theta all over cosine theta. Good stuff. Okay, now that I've got them over single fraction bars, so I've simplified the numerator so it's a single fraction bar. I've simplified the denominator so it's a single fraction bar. Now I can multiply by the reciprocal. So I can go cosine theta plus 1 over cosine theta multiplied to cosine theta over sine theta cosine theta plus sine theta. Okay, so there's a couple things going to happen here all of a sudden. First thing that's going to happen is those are going to go away. Those are both things that we can do. But this other one, this cosine theta plus 1, I don't have it a cosine theta plus 1 that I could cancel out. But in this denominator here, which I'm just going to highlight, in the other side, I have a sine theta and a sine theta. I have two terms and both of them have sine theta, so I can factor out sine theta. So this is hard for me to explain even in class when I'm standing there and I'll point at it with my pen and try and tell you it when I'm trying to figure it out or trying to get you to figure it out. But what I have here now is this. This is over 1 because we crossed out the cosine thetas. And I can factor out sine theta from both of these and I'm left with cosine theta plus 1. Now I'm going to highlight that sine theta. I factored it out of both of the terms. So if I take sine theta out of sine theta, cosine theta, I'm left with cosine theta. And if I take sine theta out of sine theta, I'm left with 1. Now what this does is it creates this situation where I have cosine theta plus 1 in both of these things. Okay? And that leaves me with just 1 over sine theta. And 1 over sine theta is equal to cosecant theta. Okay, so that's got a lot of stuff going on in it, that question, but it's an important question. A lot of fraction math happening. Very confusing as you're working through these things, but you have to be confident in your algebra and you have to make sure that you're not doing any weird reducing mistakes. Just a couple of things before I kind of leave you here. You're not allowed to write cosine or COS. You have to write the argument with it, so the theta. You see that I've tried to make my notes all have theta. Sometimes it's cosine X or cosine beta or something else. But make sure that you keep your thetas around. You're not allowed to write just SIN. If you just write SIN, it's now just the word sin. It's got nothing to do with trig anymore. It's only sine if it's got an argument beside it, so some variable is attached to it. So don't get into the filthy habit of not putting them there. Also, if you're confused as to whether something's going to work with the algebra, often a trick that I will use is putting numbers in. So for instance, is like say I have a plus b divided by a, and I go, can I cross out the a's? Like, can I go boom, boom, and I get b, which is the equivalent in trig world is this one. You know, cosine theta plus sine theta over cosine theta, is that equal to sine theta? So what students do is they go, I think you probably understand the a plus b over a, you can't cross out the a's, but then you see it in trig and you go, maybe I can cross out the cosines. No, you can't. It's the same bad mistake. If you're having problems with this, put numbers in, like replace the a's or the cosines with a specific number like 5. So 5, and then another 5, and then take the b out, replace it with something like a 2 or something like that. Say a 10, just to make it easier to understand. Right, so let's say those 3 things and we put them all together and we say, hey, let's cross out the 5s. Well, you'd think that's ridiculous now because you know that you probably go the other direction. You go, hey, 5 plus 10 is 15. 15 divided by 5 is 3. That answer is 3. But if you cross out the 5s, that answer would be 10. Now that should be the thing that, you know, the ding, ding, ding part in your brain that's saying this is not okay. So you can't cross out the 5s, you can't cross out the a's, you can't cross out the cosine thetas. So in a thing like when we're looking at this part, right, the cosine theta plus 1 over cosine theta, I often have students think, oh, I can cross out the cosine thetas and I'm left with just 1. That's the same problem. You can't just cross out parts of those things. They have to be something that gets crossed out fully if it's a binomial. So that's why I was striving to get cosine theta plus 1 in both of those things. So be careful. Think of this idea. These are all the same. So don't treat them differently when you're doing trig or doing algebra or doing just regular number math. You can't just cross out the 5s. So that's what I'm getting at when I do these questions. Anyways, that's the end of this. I'm going to do the other questions. They might be small. I'm going to try and squeeze them in right now, and then I'll post it up so you can see them and you can have a look at them. Go to the outline and do whatever's on the outline. There's an extra worksheet in the files. It's named in the outline so you can find out which one it is. That's more questions just like this. I would strongly recommend doing that first and mostly if you're only got a certain amount of time. There's textbook questions, I believe, too, and you can do those later if you want. I was trying to pick and choose textbook questions that were more pertinent to what I really need you to understand in this section. So anyways, have a good day. I'll try and mark your last assignments today, so you should get your last show you knows today, so you should get that mark back to you and you can have a look at it. From now on, every day I'm going to have a new video from this section, chapter 6, and it's a confusing one, so don't leave it all to the end or try and do the show you know without doing it. You might have been successful in some of these, but this one's you got some work to do. You got to make sure you know what you're doing. Have a good day.